So I'm pretty sure many of you have seen this sort of picture before. I would hope so. Where have you seen this before? Does this look familiar to you at all? Yeah? Kind of? No. Okay. All right. Well, we're gonna talk about angles here, and we have to talk about the parts of an angle. This picture represents an angle, but I'm wondering if you know like where the angle actually might be. What do you think? Yeah. What do you think?
It's right where two lines meet.
It's right where. Is it where two lines meet?
Well, it's like kind of like the area.
Sort of the stuff between where the two lines meet. Okay, so everyone's on the right track here. So let's talk about this. This point right here is going to be very, very important, right? What do we think we call that point right there? The vertex, absolutely. Can you guys see this green? Okay, that is the vertex of the angle. Okay, and when I'm talking about the angle, I'm talking about all this stuff here that's between. What do you think this thing is right here? This is called something. Well, what does it look like to you? It looks like a ray, right? Well, that's also called the side of the angle. And what do you think this one over here is called? The other side of the angle, right? So, as a little note, the sides are rays. So the sides of an angle are rays. Look, not so bad, right? All right, back to blue. We're on the second box. Look at that. Let's talk about types of angles. Alright, and for us right now, there's going to be 4. 1, 2, 3, and 4. So you guys nailed it around the head. These are the 4 types of angles that we're going to be talking about today. Here's what I'd like you to do. Right now, use your inspirational straight edge. Draw a picture of each one of these before I tell you what they are. Draw a picture. Alright, let's see here. Justin, where's Justin?
I'm right here.
Justin, give me, what's a drawing for an acute? How do I know what it looks like?
It's kind of like, looks like it's like a 45 degree.
Okay, 45 degree is definitely acute. What's so special about acute? Angle, yeah, what do you think?
It's less than 90.
Yeah, it's in between 0 and 90 degrees, right? So in between 0 degrees and 90 degrees, that's gonna be where our acute angle lives, all right? What about a right angle? What's that look like? Yeah.
Just
90 degrees, boom, looks just like this, right? And the way that we denote 90 degrees is by that little box, right? That box is 90 degrees. Give me an obtuse angle. What's that one gonna look like? Yeah.
It's bigger than 90 degrees.
It's bigger than 90, but less than 180. So in between 90 and 180, that's where we're gonna be. In between 90 and 180, somewhere between there. And then what about straight? Yeah, it's actually gonna, so this actually equals 90 degrees, right? This is actually equal to 180 degrees. So basically, opposite rays or a straight line are considered straight angles, and that's going to be 180 degrees.
It's a ray, so there's not an arrow on both sides.
Yeah, actually this right here, so this is still the side of your angle, and this is still the side of your angle, and that is still the vertex of your angle, right? So here's vertex, side number 1, side number 2. Here's vertex, side 1, side 2, right? And here's vertex, side 1, side 2. So they all have the vertex and the sides. They just look how. All right. In this class for geometry, there's gonna be 3 ways we're gonna name angles. 3 ways we're gonna name angles. The first way is gonna look like this. So I'm gonna give you an angle here, and give you some points here and a vertex, and it's just going to be labeled with like a number. Okay? Labeled with a number. So once you label your angle, we're going to call this angle 1. So the symbol for angle looks just like this. This right here is the symbol for angle.
Does it matter the type of angle?
Any angle. Doesn't matter the type. Could be straight. Could be, well, if we have right angle, right, we'd just say, that's a different one. That's an upside down. Right, T, but for angles, for obtuse, for acute, it's like that, all right? There's another way we could name an angle. We can name an angle like this. I could have a point, a vertex, and a point on the side. So how about A, we'll call this B, and we'll call this C. And this is the more preferred way to do it. So I have a choice here. I could say this is angle A, B, C. You see that? There's another way I could label this angle. Oh, you know what? I'm going to call this, I'm going to call this number 2, and then call this number 3. That's right. Alright, so there's another way I could label that angle. Do you guys know what it might be? Give me what do you think? Yeah.
Angle BAC.
No, that's the one that it can't be. Yeah, what could it be? Angle what? CBA. So both of these are good. What is the one that's not good? BAC. Okay, so this one is not good. So these, good, happy face. This, bad, happy face. Or no good. Yeah, was there another way I couldn't do it? CAB. That would also work. Now, here's the question, right? The question is, what makes these two good and the others not good? There's something going on there that makes it good. You could do CAB or you could do BAC. Those are the only two that work, and there's a reason why. What do you think? Yes? Very, not, yeah. B is not necessarily between because it's not a line, but it's the vertex, okay? The vertex, notice, is in the middle there. So you want to trace out your angle, like go A, vertex, and then C, or C, vertex, and then A. But your vertex has to be in the middle, right? Notice in this one, A is in the middle of the way I've labeled it. So this would be angle BAC. So BAC, I'd be talking about this angle right here. See the difference there? So that's the preferred way to do it, all right? And then the other way that's okay, but only works sometimes, is this one. Say I give you this one here, and this is B, right? I give you a point, call this, where, right? And we say angle B. Okay. The reason that this only works sometimes is because, what if I gave you this picture here? All right. I mean, this still works angle B, like this is still considered angle B. But what if I gave you this picture here and said that this was B, and this was C, and this was D, and then this point over here was R, and I talked about angle B. Do you know which one I'm talking about? No, that's why that one doesn't necessarily work. All right? So if I wanted to talk about angle B, could you give me a way that I could label it that we could all understand? Give me a way. Yeah. CBD, that would work, yes. Angle CBD, that would work. Give me another way that would work. And that's a different angle. DBC, there you go, angle DBC. And the reason that CBR didn't work is the reason that we can't label it that, because that's an ambiguous case. We're not sure what it is. So if there's just one angle, like here, it's okay to call it angle 1. But as soon as we get into a more complicated diagram like this, we no longer can do it that way. So the most preferred way is this one over here, by putting the vertex in the middle. So take a look at this one. One says angle AOB, and one says measure of angle AOB. So there's a difference between the two. So what am I talking about for when I say the difference here? So if this is A, and this is O, and this is B, then I'm actually physically this one right here, this physically represents the angle AOB. If I gave you that same picture though, over here, A, O, and B, and said that this was 51 degrees, then the measure of angle AOB would be 51 degrees. But angle AOB is just the actual physical angle, the space between them. That's the difference between those two notations, right? If there's no little m in front of it, that means we're just talking about the angle that happens to exist. If there's an m in front of it, we're talking about the measure of that angle. Okay? You know the difference between those two? So, and we're always talking about degrees. Not a trick question here. If I'm talking about the interior of angle ABC, so inside angle ABC, could you guys put a dot, or could you put a point that's inside angle ABC? Go ahead and do that right now. All right, did somebody put a point, I don't know, here? And call that, if I call that point X. Is point X on the inside of the angle ABC? Yes, it is. Okay, is point R over here on the inside of angle ABC? No, that's the exterior, right? Okay. What about point A? Is that interior or exterior? Or neither? It's neither. It's on the side. Very good. Point A is a point that's on the side of angle ABC. It is not on the inside. Not a trick question. Congruent angles. When you see the word congruent, What do you think of? There should be two things that you think of. What are the two things you think of? Same size, same shape. So congruent. Same size, same shape. Okay. Now, do angles have the same shape, generally speaking? Okay, fair enough. Just like line segments have the same shape, right? Just like points have the same shape. Okay, so fair enough. So what we're looking for then is we're looking for size, right? That's going to be the most important part for talking about congruent angles. So if I give you this angle here, and I label this point A, and I label this point B, and I label this point C, and I say that this is a 27-degree angle, and I give you this other angle over here that happens to look a little bit different, and I call this point P, Q, and then R. Alright, I can say that this is also 27 degrees. Do you have enough information to now say that these two angles, I'm going to say angle Q and angle A? Well, first of all, am I allowed to say angle Q and angle A in this case? Oh, sorry, B. Thanks a lot. Angle B. Thank you. Yeah, can I do that? Am I allowed to do that? Is that a proper way to label these types of angles? Yeah, because there's no other parts of the diagram. It's good, right? Angle B, we know what we're talking about. Angle Q, we know what we're talking about. So would you say that angle Q is actually equal to angle B? Yeah, what says that? The fact that they're both 27s, right? So I know that for a fact. Now, since they are equal, would you say that they have the same size or shape by being equal in measure? Same. If they have the same size, if they're both 27, they have the same size, the same size angle, right? We're just talking about the actual shape of the angle, right? At 27 degrees. Angles generally have the same shape, right? It's an angle, it's a space between two rays. That's how we describe its shape, right? Kind of an abstract concept. So size is important. So since they are both guaranteed to be 27 degrees, we can then say angle Q is now congruent to angle B. And that's what we're looking for. So adjacent angles are two angles that are next to each other. So that begs the question then. So let me give you a little tiny picture here. So I'm going to give you this picture of two lines. Okay? And then I'll give you this picture over here. And I'm going to call this angle 1, and I'm going to call that angle 2, and I'm going to call this angle 1 and call this angle 2. Okay, in one of these pictures, angle 1 and 2 are adjacent. In the other picture, angle 1 and 2 are not adjacent. Okay, yeah, what do you think? They're adjacent in the second one. Are you talking about this one over here? Why are you talking about that? Why do you think that's true? Yeah, they're like right next to each other. You're absolutely right. So what's the deal with, how about the first picture there?
They're actually a part of each other.
Yeah, so this angle, so here, let's talk about, okay, angle 1. This is angle 1, right? You agree with that one? Okay. And then I'll call this angle 1 over here. Okay. And then I'll do, how about blue? There's angle 2 right there. And then here's angle 2 over here. So it's certain colors, right? That's kind of cool, right? So what do you notice then? What do they share? They share a side, right? What do they not share over there? But they would share the same vertex though, right? Okay. Alright, so adjacent means next to, right? They gotta have to. Now let me give you this picture over here. Okay? And this is not a trick question again. I'm just drawing pictures for you. Right. Let's do that one, and then let's do like this one over here. So I'm gonna call this angle 1 and call that angle 2. Okay. Are those adjacent?
Yes.
No, those are not adjacent angles, right? Why are those not adjacent? They share part of a side, right?
Oh, they have to share the whole side?
Yeah, they share the whole side. They also have to share what? The vertex. Yeah, they share the same vertex and the same side. Then they're adjacent, right? They share the same. These are non-adjacent angles. Those are not adjacent down there. Angle 1 and angle 2. So here we go. That's angle 1, and then here's angle 2. Those are not. So they do share part of that side, but that's the common vertex, common side. Right? Well, what's here? What about this angle here? What do you guys think? What if I gave you this picture? Here's angle 1, and there's angle 2. Are those adjacent angles? Why? What makes them adjacent?
Share vertex on the side.
Yeah, that right there, and then what else do they share over here? There we go. Same vertex, same side. Those are adjacent. So you see the difference now between the two? This feeling good? Alright, so the bisector of an angle. What do you think the bisector of an angle means? What do you think it means? It's not a trick question. Yeah, it cuts it in half, right? So, right here, it is a ray that cuts the angle in half. So that's the bisector of an angle. Alright, so how to mark up a drawing here. Let's talk about congruent segments for the first part. So, in geometry, we're going to be marking up a lot of drawings here. So if this is a segment, and that's a point, line M, and I want to show that two segments are congruent, meaning they have the same what and what for congruent? Size and shape. Okay, good. So the way that we're going to mark up a drawing for congruent segments is we're going to use little tiny tick marks. So I'm going to say this segment and this segment are congruent. Alright? That's going to be the way that we show that those two segments are congruent. But then the question arises then, well, okay, well, what if then we have more than just this? What if we have like a box, say, for example? Okay, I know that's not very good, but if I have that box right there and I want to show the segments that are congruent, I would say that this segment and that segment are congruent, but there's another pair of line segments that is also congruent, the top and the bottom, right? So what do we use? I see everyone that we use two little tick marks, okay?
They're also congruent.
Meaning that those two are congruent to each other but not the sides. See the difference? Okay.
So what if you put two tick marks on the side instead of the top and the bottom?
Well,
You could do that too.
I could do that too. Yeah. Let's say I had this drawing, all right? And let's say I can draw it really good. So let's say I had this, say I have that and that, longer, and that. Okay, I'll try my best. So let's do this. This segment is congruent to that segment. What other pairs are congruent? This little guy and this little over here. Is there another one?
Yeah.
Yeah, bump, 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 and then bump, bump, bump. So could I be doing this all day long? Yeah. Generally speaking, a figure, these are called figures, right, that I'm doing here, they're not going to have more than 4 pieces that are congruent. After that, it gets a little crazy. So that's how we do congruent segments. What about angles? All right. Well, here's how we're going to mark up angles. So let's say I have this, okay? We do little arches. So that arch there and that arch there. Those arches tell me that they are congruent angles. I like to also do this, to mark them up like that, and say I have an arch with a line. Okay? So I have an arch with lines that tell me that those are congruent. There's another way that you could do it. Alright? Let's say I have this. Let's say I've got this figure over here. Say I've got that one and that one, right? Those are congruent, but are there another pair that's congruent as well? Yeah, what would it be? Yeah, so the other way you can do it is you can do double arches here. That's one way you could do it. Or if I gave you that same picture again, looks like this, the way that we would do it is like this. You go single ticks there, double ticks there. Okay, how do we mark up a right angle? What do we use? Yeah, we use a little box here. That tells you that's right. Okay, here's a little bit of a warning for you. And the warning is this. If you see this picture in the book, is that a right angle? No, it's not. You can never assume that it is. What tells me that that's not a right angle? There's no indicator that says that it is, okay? So, boom. Now is it a right angle? Yes, because I was told. You can never assume. There's only one thing that you are allowed to assume, and that is that every line that you see is straight. That's the only thing you're allowed to assume, okay? So if I gave you this picture right here, and I said, are those two angles congruent? You would say what? No, because unless you see this, now you can say they're congruent. Never assume that it is based on the drawing. It has to either be told or has to actually be in the